Welcome everyone. The study is entitled Numerical Assessment of the Seismic Vulnerability of the Historical Earthen Remains of the Mansourah Enclosure located in Tlemcen, Algeria. Influence of Geometry and Identification of Critical Damage Zone. This study focuses on Algerian historical heritage, with particular emphasis on the Tlemcen region. Structures built of earthen materials constitute a significant part of this heritage. However, their seismic behavior remains insufficiently studied. The main objective of this work is to assess the seismic vulnerability of the historic enclosure of Mansourah and to analyze the influence of geometry on the identification of critical damage zone. 6 representative structural elements of the Mansourah enclosure were selected, featuring different shapes and geometric configurations taking into account. Their precise located are indicated on the site plan figure 1. Figures 2 to 7 illustrate the geometric shapes and dimensions of the structures selected for our study. Physical, mineralogical, and mechanical analysis were carried out on samples collected from the site. These investigations allowed for a precise characterizations of the material's behavior and the determinations of the properties necessary for modeling. A nonlinear time history dynamic analysis was performed using ANSYS workbench. The material behavior was modeled with an elastoplastic Drucker-Prager criterion. Rayleigh damping was adopted with coefficients derived from model analysis. 2 seismic inputs were applied, an artificial Tlemcen accelerogram and a real Boumerdès earthquake. Let us now review the results. 5K physical indicators were analyzed: principal, tensile, and compressive stress, Drucker-Prager equivalent stress, equivalent plastic deformation, and maximum displacement. The maximum values for the 2 seismic excitations are summarized in tables 3 and 4. Under the Tlemcen earthquake, the equivalent stress maps show that damage is mainly concentrated at the base of the intermediate walls, at the end of freestanding walls, and in the thickness transition zone of tower walls. The equivalent plastic deformation maps confirm this damage distribution, highlighting the same area of plasticization. The comparison of seismic responses show that the higher magnitude Boumerdès earthquake generally induces larger responses, while the frequency, content, and structural geometry explain the higher responses observed from some structure under the Tlemcen earthquake. The results showed a spatial coherence of the critical zone that are most exposed to damage for all the case study. These zones are located mainly at the base of the intermediate walls, at the ends of the free walls, and in the thickness transition zone of the walls constituting the tower. The vulnerability classification from the most critical to the most stable case was found to be as follows: structure 5, 4, 1, 3, 2, 6. This finding facilitates the orientation and prioritization of strategies for the reinforcement and preservation of historic monuments built with rammed earth.